26th of March here, Funsock Friday. You guys will be able to use inverse trig functions to find measures of angles, section 7.6, okay? So make sure everyone's on section 7.6 for this. Yes?
Is our test Thursday?
Actually, no.
Okay.
It'll be... the Wednesday after we get back.
My advisor. Why?
Because that's will be the next class. Because we have another section in this after this one. That's not notes. Okay. Inverse trigonometric ratios. So, for every map function, okay, which these trig functions are functions, okay? It's like squaring is a function. Well, the inverse or opposite of that is square rooting. What is the inverse or opposite of addition? Subtraction. What's the inverse of multiplication? Division, okay? So every function, every operation has an inverse that undoes it, right? Okay? So we have an inverse for sine, cosine, and tangent. So these are three different functions. Jackson, eyes open. Okay? We have three different functions here with sine, cosine, tangent. So we're going to have three different inverses. And what will happen is these will undo that function. So right now we are taking the sine of angle A as a function on the angle. We're taking the cosine of angle A, a function on the angle. And the tangent of angle A, a function on the angle. So in order to undo it, if sine of angle A is equal to x, then the inverse sine of angle A is equal to, let me try that again. Then angle A is equal to the inverse sine of x. I misspoke. So what you do is you take the inverse sine of both sides. So we write that as sine to the negative first. We do not read it that way. We don't say sine to the negative first. And we definitely don't say sin to the negative first. How we read that is we say inverse sine. We don't get creative with this name here. Like addition, subtraction have different names for being the inverses of each other. Or multiplication and division have different names for each other, even though they're inverses of each other. We just literally call it sine, inverse sine. And they undo each other. So what do we think is going to be the inverse of cosine? It's inverse cosine. The inverse of cosine is inverse cosine. So if cosine of angle A is equal to x, well, angle A is equal to the inverse cosine of x. We took the inverse cosine of both sides, just like you subtract both sides or you divide both sides, right, Jackson? Do we need to fight to keep our eyes open, buddy?
I forgot Jackson was here.
Okay. All right. Tangent of angle A equals x. What do we think the inverse of tangent is going to be? What do we think the inverse of tangent is going to be called? Inverse tangent. And we're going to write it the same way we've been writing the others. Tangent to the negative first. But we don't read it that way because it's not actually to the negative first power. If it was to the negative first power, negative exponents actually make you reciprocate or move it to the bottom of a fraction. That's not what it's doing here. It's just the way we notate or write it. Okay, notate, think notes, the way you write things. So these are our three inverse trig functions. Notice, did we mix them up and say, hey, inverse sine goes with cosine? No, we didn't mix them up and say inverse sine goes with cosine. Inverse sine goes with sine. Inverse cosine goes with cosine. Inverse tangent goes with tangent. So what happens here is, let's say we have a problem on this next page that says, hey, find the measure of angle C if the sine of angle C is equal to 0.24. Okay, I put measure, little m in there. Because it probably should be there. All right, so we're finding the measure of angle C if sine of angle C is equal to 0.24. So sine is always a fraction. So just like how on our warm-up, I clicked out of it earlier, but it said we end up getting the sine of angle V to be 8 over 17, correct? Yeah. Okay, so we could actually take 8 divided by 17 and get a decimal, right? Okay, somebody do that in their calculator. Take 8 divided by 17 and give me a decimal, and let's go to 4 decimal places.
0.4705. Or 6 actually.
0.4706.
Okay, so sine of angle V is approximately 0.4706. This was our warm-up. I just flashed back to it for a moment. Yep, you're good. So, I can actually tell you now, knowing this, what angle V is. I can go through and I can find on my calculator, and I'll show us how in a moment, that angle V is approximately 28 degrees. I can now find that information. Because we knew the sine of angle V was 8 over 17, or approximately 0.4706 in decimal. I did that by taking the inverse sine of both sides, because the inverse sine undoes it, gets the angle by itself. So what happens mathematically here in example 1 is, I'm just going to rewrite the problem to start. Sine of angle C is equal to 0.24. I'm going to take the inverse sine of both sides. I don't really have room to write it in front of it on the second one, so I'm just going to write it up there. Now to notate this, to write this here, we put the inverse sign in front of whatever we're taking the inverse sign of. Just like how we put sine, cosine, tangent in front of that angle. Same idea, we're going to put inverse sign in front of what we're taking the inverse sign of. What was your question, Seth? Yep, I'll tell you that in a moment. Now, what happens here mathematically is just like multiplication and addition, multiplication and division undo each other, right? Okay? It's like a moment ago when we had this, don't write this one down, okay? A moment ago when we had like 8 over D, I think it was D over 8, and we multiplied by 8 over 1, we said, oh, those reduce, right? And we're just left with D. Does that sound familiar? Hope so. We just did that about 20 minutes ago. When we have the same thing here with inverse sine and sine, they undo each other. And what do we see that we're left with? What do we see that we're left with on the left-hand side here? C, angle C. So angle C is going to be equal to the inverse sine of 0.24. Go and write that part down. And angle C is going to be equal to the inverse sine of 0.24. Now, if you have a calculator, go ahead and get that out now. I'm going to speak first to the scientific calculators like I have, the TI-30s. Okay? If you have this calculator, you see right above the sign button in a slightly off different print. Do you guys see the inverse sine button?
What?
On these calculators, Bailey.
Oh.
Okay? Ryan, do you see that?
Mm-hmm.
Okay, Kevin, do you see that? So right above the sign button, do you see the inverse sign logo? Okay. Jackson, Seth, do you guys see that?
I've already done this.
Cool. Okay. Take that as a yes. So what you would do is you would push that second button, because you notice the second button matches the same shade. You push the second button and then you push sign. Okay. Those with iPhone, Android, turn your phone sideways. Make sure portrait orientation lock is off. Now, when you turn it sideways, you should see somewhere toward the top left of your calculator an option to push second. Push that button.
Wait, where?
Okay? Somewhere toward the top left, you should see an option to push second.
I don't see second.
No.
It's not second. It's a couple arrows.
On the Android calculator, it's 2 arrows, left and right, going opposite directions. Okay? Is everybody in the second function?
Yes.
Okay? You guys see now how instead of sine, it was replaced with inverse sine? You guys see that?
Yes, sir.
Okay, so you now click, if you have an Android phone, Android only right now, Android in the scientific, okay, you click inverse sine, and then you type in 0.24, close your parenthesis and push enter. Once again, if you have an Android or a scientific of some sort, you push inverse sine, 0.24, end parenthesis. If you have an iPhone, you first type in 0.24. If you have an iPhone, or some sort of Apple calculator of any kind, type in 0.24. Then you go to inverse sine. Make sure you are on second to do the inverse sine. And what do we get here to the nearest? Let's go 4 decimal places on this one. So we end up getting measure of angle C to be approximately
13.8865. Okay, Seth.
Okay. Hey Seth, if somebody's already saying it, you probably don't need to talk over them, okay? Seth, does that make sense?
Yes.
Alright, thank you.
I did not get this.
Okay, you did not get that? Okay, if you didn't get that, tell me now either by raising your hand or saying it out loud so I can come around and help you. Did you get that?
Yeah.
I will have you wait one more moment, please.
Okay.
You're good now. Yep. Okay, anyone else not get exactly that? You did? Okay, that makes sense. So you it was routing it for you earlier.
Are you not just saying 4 decimal places?
On the next one?
Yeah.
Yep. What's going to be different on this next one, though? Cosine. Go ahead and try number 2. Or it's going to be letter B, I should say.
Do raise your hand.
We have to be very careful that we use cosine this time, not sine or tangent. So when we have cosine of angle C is equal to 0.37, we have to say, okay, I want C, so how do I undo cosine? Oh, I take the inverse cosine. It's important to note that we are not dividing by cosine. That is something entirely different. Okay? We're not dividing by cosine because cosine is not multiplying with angle C. Okay? I know they're written next to each other, but they're not multiplying. We're taking the cosine of it. So we take the inverse cosine. So the inverse cosine and cosine undo each other, and C is equal to the inverse cosine of 0.37. And we end up finding out, when we type that into our calculator and let it do the work, that the measure of angle C is approximately to 4 decimal places, 68.2844 degrees. Make sure we have that degree label on there, okay? If you didn't put the degree label, write that in now so you remember it later. Okay? Yes, Ken.
Okay. So how do I never mind, just keep going. You'll probably answer it. If not, it'll come back to me.
Cool. Okay. No, you're good. Anyone that still need or have questions on example 1A or B? All right, continuing on. So example 2. Find angle Q to the nearest tenth of a degree, okay? So here, do we have any angles? No, but we're looking for angle Q, right? So we can call angle Q... Yeah, we do know the 90. We know it's the right triangle. So I can call angle Q X or theta. Either way is okay. Okay? That's the angle we're looking for, right? Angle Q. So what are the sides in reference to this angle? By in reference, I mean opposite, adjacent, hypotenuse.
8 and 15.
8 is what? Adjacent. 15 is hypotenuse. Of our SOHCAHTOA, TOA, we're still using those. Which one, sine, cosine, tangent, would this involve? Ka, because we have the adjacent and the hypotenuse. So we'd be focusing here on ka, okay? C-A-H. So we set up cosine. Now, when we set up cosine, we take cosine of the angle. In this case, what angle are we talking about? Q. So cosine of angle Q is equal to blank over blank. 8 over 15. So very similarly, it doesn't reduce. Very similarly to what we did last section, we set up our sine, cosine, tangent, and we fill in what we know, and we leave what we don't know. So before, though, in our last section, we didn't know one of the side lengths, right? And we multiplied and divided to figure out a side length. Here, we know the side lengths, but what don't we know? We don't know Q, the angle. Very good. So if we're trying to find the angle, we need to undo cosine. We're taking the cosine of it, so how do we undo taking the cosine? Not divide. Take the inverse cosine. Cosine is not multiplying with angle Q. We are taking the cosine of it. So we need to take the inverse cosine of it. Did I answered it, Kenny?
No.
Oh.
How do we know when to use cosine or inverse cosine? Like how do we...
Okay, so whenever you're setting up the problem, you always set up the regular trig function.
Okay, but how do we know that it's like time to use?
Inverse cosine?
Yeah, how do we know
Okay.
that it's not, that's not the answer?
Okay, so the reason we know we want to use inverse cosine is because what are we finding? We're finding angle Q. Is angle Q by itself?
Oh, okay, yeah.
No, it's not by itself. So we say, well, how do we get it by itself? We have to undo cosine. Well, how do I undo cosine? I do the inverse.
Okay.
Does that make more sense?
Yeah.
All right, so cosine and inverse cosine undo each other. And we get angle Q is equal to the inverse cosine of the fraction 8 over 15. And then we type that in our calculator and let it do the work and say, hey, the measuring angle Q is blah, 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 blah. Don't blurt. So, for this, if you have an Android calculator, this is pretty nice. Or one of my scientifics, this is pretty nice. If you have an iPhone calculator, it's a little less nice. So, Android or my scientifics, you type in second cosine for inverse cosine. You put in 8 divided by 15. You close your parenthesis, and you got it. Okay. The iPhone, you would have to do first 8 divided by 15. Yep. It doesn't matter. Yep. And then you do second cosine for the inverse cosine. Okay. And then you should get it. Okay. So Androids and scientifics, you just type it in as you see it. Inverse cosine. 8 divided by 15, close your parenthesis. So the scientifics and Androids, because Androids are scientific calculators, you just type it in how you see it. The iPhone, you have to kind of rearrange it a little bit to make it work.
This iPhone's garbage.
Why does Apple have to be so hard to do?
Okay.
It's garbage.
I'm seeing a lot of biases come out. Presley, to the nearest tenth of a degree, so the nearest tenth, guys, nearest tenth, what is our answer? Very good, 57.8. So the measure of angle Q is approximately 57.8 degrees. Did anybody not get that? All skin, did anybody not get 57.8 degrees approximately? Okay, good. Any questions on number 2? All right, our last example for today is number 3. A road rises 10 feet in a horizontal distance of 200 feet. What is the angle of inclination? Okay, well, is there any non-important information here?
No.
Not really. So do we need to underline right now?
No.
Not really, but what should we do?
Underline.
I just said we don't need to underline. Picture! What are we drawing here?
A triangle.
A road. It's going to be a triangle, right? Landon, how do you know it's going to be a triangle?
It's going to have to be a triangle.
Okay.
How else are we going to do this?
Because we've been doing triangles for the last 3 chapters, right?
I know.
Okay, right, Jackson? Okay. So, we have a road, and it goes up 10 feet. So it goes up 10 feet in a horizontal distance, horizontal straight left and right, of 200 feet. And so we have this road doing that.
Or like a ramp.
So this is actually the road here.
It's a ramp.
It's the road. Roads can be at an angle. Drive right by our school
So you never
on Highway 75 there. What?
Have you never seen a hill?
Maybe.
I live on a hill. Then you would know that it's not a random. Maybe I live on a dirt road.
Okay, country roads.
It's a road.
Okay.
Yes, it is.
It literally has road in the name.
It's a dirt road, but
so-
it's not a road though.
Okay, anyway. So, if it rises 10 feet in a horizontal distance of 200, what do we think the rising vertically and horizontal would create? What kind of angle?
The pitch.
90 degrees. I'd hope so too.
Find out 85.
Okay? We want to know, what is the angle of inclination? What does inclination make you think of?
Incline.
Incline. So going up. Which of the other two angles would be the inclination angle, or the angle of inclination?
Hypotenuse. Oh, no.
Between the road and the 200 feet. So this bottom left angle is the angle we're looking for. That's our x, or theta, if you will. Theta, remember, is our x for angles often. It's an O with a line through it. Actually, I'll put theta this time. It's a 0 or an O with a line through it. So we want to know that angle. So in reference to that angle, what sides are we given?
210.
210. Okay, well, we're given 10 and then 200. Which sides are those? 10 is which?
Adjacent.
Nope.
No, opposite.
Opposite. 200 is adjacent. So, we can write out SOHCAHTOA again. Is it a bad idea for you guys to continue writing SOHCAHTOA for your worksheets and stuff? No. Which of these three deals with opposite and adjacent? TOA. What trig function is that? I think I heard it. Tangent. So we take tangent of the angle. What's our angle this time, though? Theta. Tangent of theta is or equals what?
10 over 200.
10 over 200. Opposite over adjacent. You can reduce that one if you want, right? You don't necessarily have to because your calculator will do that work for you, but if you want to reduce that to 1 over 20, you can.
If you let the calculator do it, is there like less room for error?
Sure. Because I guess you could make a mistake doing that. You probably won't make a mistake reducing 10 over 200, but I guess it's possible. You could also argue that in this case, the error on typing it in wrong could be about the same as reducing that wrong, but it depends on your preference. Good question though. So now, is theta by itself? Do we want it to be by itself? So how do we get it by itself?
Inverse of tan.
Yeah, you do the inverse tangent. We have to undo tangent, so we take the inverse tangent. Now, if we do it to one side, do it to both. That's like Algebra 101 right there. Whatever you do to one side, you have to do to the other. Now, inverse tangent and tangent do what to each other? They undo each other. And what are we left with?
Theta equals
Theta?
inverse tangent of 10 over 200.
Very good. Very well stated, Seth. Theta is equal to the inverse tangent of 10 over 200. Yes, Ken.
Okay, so if it doesn't say up there like to the nearest tens or hundreds or whatever, we just put the whole thing.
Great question. If it doesn't say, ask me or write down whole tenth. I'd be pretty lenient if I don't give an instruction. Okay? Great question. Okay. So theta is going to be approximately, I did this one to the nearest tenth personally, so let's just go nearest tenth. What? 2.9 degrees.
That's pretty cool.
Job to job. Not if it's Kelvin. No, especially if it's Kelvin. Whoops. Not if it's Celsius. Not terrible. It's not warm. I just say it's still pretty cool.
Yeah, that's like 30.
It'd be like 36,
Yeah.
around there.
Like 30 Celsius is about like 36, 37 if you're 60 Fahrenheit. I'd have to look.
I don't think that's accurate.
37.22 degrees Celsius or Fahrenheit.
No.
So it's still
All right.
pretty cold. It's
Yeah, I'll say to go from Celsius to Fahrenheit, you multiply by 9 over 5, and then you add 32.
I just got a temperature thing here. I got Kelvin too. That's negative 454.45 as Fahrenheit in Kelvin.
It's a good thing I didn't drive the Durango today.
Why?
We don't have heat.
Oh, awkward.
Gotta fix the things.
Any question on this, guys? Okay. Number 4. On 5, it's actually not supposed to be there, so that's okay. On 5, we have enough information, but on number 4, take it though, Kevin.
It's perfectly cut off.
The one we are missing, I'll put in orange here. Anyone? And it should be on the left-hand side of that triangle.
The whole puncher just
It's literally right where the hole punch is. The hole punch took it out.
I mean, fine, it cut off a little bit.
That's just not okay.
It's still hypotenuse.
What about number 5?
It's sold the opposite leg.
Number 5 is cut off.
Yep, that's okay. 5's okay. Yep.
It's not supposed to